All right, everybody. We hope you're enjoying your lunch. You can still continue with that. But we're going to get going on our fabulous farmer panel today. That's on, what's the title? Sustainable, right? Sustainable farm practices for sustainable nitrogen cycling. So we've got three farmers here with us today. I'm going to give a brief introduction of all three of them, and then we'll have a few set questions for them that we'll go through and have each one give a response to, and hopefully we'll have a little bit of time for questions at the very end. So first we have Bruce Rominger. He's a fifth-generation farmer just here in Winters. They have 4,000 acres of irrigated row crops. It's everything from tomatoes and alfalfa, including rice also, safflower, sunflower, onions, oat hay. And they also have 2,500 acres in the hills where they run some sheep and cattle. Bruce has been in leadership on many organizations, including, he was still with the Yolo County Flood Control and Water Conservation District. Great. And then we have Dr. Mike Turkovich. He's the third-generation farmer, also here in Winters with Button and Turkovich Ranch. They have approximately 6,000 acres with about 16 different crops, including both organic and conventional tomatoes and alfalfa, organic rice and organic barley. And then they also have several other crops, seed crops, and wheat, safflower, beans, and also some perennial crops, walnuts, oranges, prunes, and wine grapes. And finally, at the far end there, we have Tom Willie. He and his wife operate a 75-acre certified organic farm in Madeira. They grow a wide range of Mediterranean vegetables year-round, and they have an 800-member CSA. And they also serve various specialty markets and restaurants up and down the West Coast. So I will begin.
There's a lie in there because we had an 800-member CSA. We just sold it to the Food Commons last week.
Okay, latest developments here. Good. Thanks for keeping us up to date. All right, so we're going to start with a general question for them, which is I'm going to ask each of you to basically describe your approach to nutrient management on your farm, especially regarding nitrogen. And if you can tell us something about your overall goals and if there's any particular practices that work really well for you or that you want to highlight or any technologies that you use, please let us know. So can we start with Bruce here?
All right. Thank you. The nitrogen management on our farm has changed quite a bit just in the last few years, certainly with the awareness of nitrogen, nitrous oxides emissions and the global warming impact it has, and now with the groundwater contamination with nitrates, we're all looking at our nitrogen a lot more closely. We've been taking soil samples for many, many decades, and we've been talking with agronomists about how much nitrogen and listening to the cooperative extension people about how much nitrogen a processing tomato crop takes or a wheat crop or whatever else we grow. But now we've just fine-tuned that quite a bit more. And so with the conversion to drip irrigation, which all of our tomatoes are grown under drip irrigation now, and further testing, which is soil testing at least twice a year, and then petiole analysis throughout the season, and also our water testing, so we know what's coming in our well water or canal water, so we know how much units of nitrogen we're getting from that. We are putting some manures, not always on every field, but in some of our conventional tomato fields also, so that's put into our nitrogen budget. And then I'm working with an agronomist now, so we are just fine-tuning that, and not only how much nitrogen we put on, but how we put it on in what sequence during the course of the season on each field based on the planting date of that crop. So that's primarily what we're doing, and we are looking at the P and K and those balances also, and adding potassium has become a significant addition to our fertilizer program in the tomatoes now, and that's where we are right now, theoretically, we're putting on exactly the right amount of nitrogen at exactly the right amount of time, at right time for our tomato crops based on the expected yield we're getting. The reality is, do we have some monitoring that's going on that tells us none of our nitrogen is getting below the root zone? No, we don't. So we're trying to do better, but we still have some improvement to make and some more data that we need to collect before we know we're doing a really good job.
All right, thank you, Bruce. Mike Turkovich.
Yeah, so the way we think about nitrogen management or fertilizer management on our ranch is we look at it as an input, and so in order to be as efficient as possible, we want to basically optimize that by minimizing inputs without hurting or potentially increasing yields. So when you look at it like as a cost, you obviously you're going to manage it that way so that you're not going to wait. You don't want to waste it for two reasons. One, you don't want to hurt the environment, but also it's not cheap. So as technology has improved, our efficiency has improved. Like Bruce was saying, we use a lot of drip now, and if you right place, right time, right source, you can get it really efficient. So that's kind of how we go about looking at the nutrient management on our ranch.
Okay. Okay, Tom, Willie.
If I don't answer directly the questions that are put to me, then just imagine that I'm a politician, okay? In the absence of knowledge, rely on nature. That organic farmer's motto should be the motto of all agriculture. Since the Haber-Bosch revolution notwithstanding, it's estimated that 70% of all fertility, even in the most sophisticated high-input conventional agriculture, is mediated through natural systems. Organic farmers, myself included, by legal definition, rely on nature's age-old recycling system, the foundation of fertility on this very planet, to grow our crops. There's no nutrient cycle more complex than that of nitrogen, shifting between 7 oxidative states and the reductive state of ammonium, all driven by microbes which belong to an ecology, soil microbiome, if you will, the immense, elegant complexity of which we're just becoming aware of, let alone understand. I just want to point out a study that I came across that was published in PNAS in 2013 of a isotopically tagged nitrogen fertilizer experiment that's been going on since 1982. Let me just quote you a sentence or two from the abstract. We found that 65% of the applied fertilizer nitrogen were taken up by plants, whereas 12 to 15% of the labeled fertilizer nitrogen were still residing in the soil organic matter more than a quarter century after tracer application. About 12% of the applied fertilizer had leaked toward the water table during the 30-year observation period. We predict that additional exports of nitrogen in labeled nitrate from the tracer application in 1982 towards the water table will continue for at least another 5 decades. Therefore, attempts to reduce agricultural nitrate contamination of aquatic systems must consider the long-term legacy of past applications of synthetic fertilizers in agricultural systems and the nitrogen retention capacity of agricultural soils. Maybe you need to cut me off there and I'll...
Well, yeah, I was going to say that's a great introduction to your philosophy. Are there examples you can give of how you use that when you're actually growing the crops in the field? How do you
Well,
implement that?
I mean, we operate mainly on a compost-based fertility system, and I think we apply approximately what I think is the standard for high production organic vegetable farmers in the state that I'm aware of, which is around 10 tons to the acre per crop cycle. Now we farm 12 months out of the year in a very generous, Mediterranean climate just outside of Fresno, and so we have anywhere from 1 to sometimes as many as 3 of those applications on a given piece of ground in a 12-month period. We do soil testing once a year, basically to balance our major cations. We've never been all that interested in nitrate levels because we find that they seem to react like a yo-yo all through the year. But we have our farm broken up into 8 blocks for soil sampling, and this February my lowest blocks measured 2 parts per million nitrate, and the highest one was 40 parts per million. So I'll come back to some more explanation of that in my next opportunity. I don't want to hog too much time here.
Okay, thanks.
Okay.
And do you do any crop rotation, particularly with nutrient management in mind?
Oh, we certainly do. Obviously a very rational, or what we think is a rational crop rotation. We have 4 main fields, and we have been growing as many as 50 different vegetable crops. So we classify them as Solanaceae or potatoes or whatever the rotations are, and we have a strict rotation through those 4 fields, and so it's a 5-year rotation. Yeah.
Okay, and what about Bruce and Mike, rotation for nutrient management? Is that something that comes up at all?
Well, in our situation, the rotations are more in the disease management area primarily. But we are, obviously, with the diversity of crops we have and what Mike has, we're all rotating our crops, all the time, putting different things, in each field. And so these crops also, in the nutrient side of things, crops are also using different amounts of micronutrients and different amounts of nitrogen. And certainly if you're doing high nitrogen crops like tomatoes, it helps to get a cereal grain in there at times. It will scavenge that and bring it back. And we do cover crops. We do some of the triticale cover crops in the winter right before our tomato crops, and that's primarily, it's not primarily, but one of the main functions is to hold nitrogen there.
Okay. Anything else from you, Mike?
It's very similar. It's not, we know we do crop rotation and cover crops too, but the primary goal isn't nutrient management. It's disease control and also the soil health and soil building. If you have something alive in the soil at all times, in theory, that's good for soil improvement. So those are more the driving factors on those particular practices.
Okay, great. And Bruce and Mike both mentioned you have a lot of drip irrigation now. And Tom, I don't know, what kind of irrigation do you use?
Our farm has been 100% drip from the time we put seed in the ground. It's been completely drip for probably 20 years since we've owned this farm. Yeah.
Okay. I want to ask, with these changes in irrigation, or you've been doing it for a long time, and also with it in mind that we're in the 4th year of a pretty major drought, is that affecting how you manage nutrients on your farm? Maybe could we start with you, Mike, this time?
It's affecting how we manage water, which is linked very closely to nutrient management. So again, we like to think that we are being as efficient as possible, so we're not wasting a lot of water, even if there isn't a drought. So the amount we're applying hasn't really changed. And the differences have come in moving water around, like if you don't have surface water or if a pump goes down. With the drought, we've had to, try to move water across the ranch, which requires a lot of logistics. And sometimes some crops you have to prioritize, and your high-value crops get the full water, and full nutrients, and your lesser value crops, sometimes you have to do deficit irrigation there and just try and keep them alive.
So when you do deficit irrigation, do you also cut back on nutrients, or how does that work?
Yeah, it would be proportional. I mean, if you think you're going to hurt your yield, then you're probably going to cut back on your fertilizer. Again, just you don't want to be wasting fertilizer and polluting the environment. So.
Okay, great. Thank you. Tom, relationships between irrigation and nutrient management?
Yeah, let me continue with a little bit of my stump speech first. Organic farmers maintain large pools of organic nitrogen bound up in organic matter in their soils. Depending on slow microbial mineralization of nitrogen from this bank account for crop needs. Some researchers are frightened by this, assuming us to be gross polluters as ammonification shifts towards nitrification. However, the presence of soil nitrate is not in itself evidence of groundwater pollution. And I want to cite, I've looked for good studies on the fate of compost nitrogen, and I've only found two that are using lysimeter, which is a catchment system below a growing crop to see exactly what kind of nutrients are escaping below the root system. One was a 12-year study in Austria that applied 4 times the total nitrogen in compost as compared to the other plot, which basically received the conventional dose of regular conventional fertility or nitrogen fertility. Over the 12-year period, that 4 times amount of nitrogen in compost never contributed more nitrate pollution to the groundwater than did that regular dose of conventional nitrogen, which was 1/4 of the total. The second one was just a 2-year study in the Czech Republic, where 2 times the amount of nitrogen in compost also demonstrated that it was not polluting the groundwater any more than the conventional chemical nitrogen fertilizer regime that they were comparing it to.
Do you think there's any way that irrigation management can affect that as well?
Certainly. The climate you're in, the rainfall that you're in, the irrigation management, it's all about management. It's all about management. Now, we happen to be in a bioregion where we're praying for our 8 inches of normal rainfall. So normal rainfall for my farm is 8 inches. So our ability to leach nitrates into the groundwater, which right now is 182 feet below the surface and falling as we speak, even if I wanted to, I'd have a hard time doing it with 8 inches of rainfall. For the last 4 years, we've only gotten about 4 inches of rainfall. And our farm being completely on drip irrigation, it allows us to manage our nitrogen availability, I think, pretty effectively. However, I've been begging University of California scientists for 25 years to come out to my farm and help me evaluate, the rationality and the responsibility of my fertility system, and I've had no takers in all that time. So it's wonderful to see all the work that's going on here on Russell Ranch. But we organic farmers, we need you out on our farms, and we need you to help us evaluate these compost systems. There's just very, very little research done on the mineralization of nitrogen out of compost and its ultimate fate in our farming systems, and we need that help, and I continue to invite you. So.
Great. Thank you, Tom. That's a great point. Come back to Bruce. Do you want to add anything to that?
Well, the drought's had an effect a little bit on us. Since we take some soil samples in the fall, and we also take them in our tomato fields just pre-plant, and one of our concerns, the really only practical time for us to put on manures are in the fall. When the ground's dry, you have a lot of big equipment, you're not doing you're not compacting any wet soils like you would in the spring. So we're always concerned that how much of that do we lose over the course of a winter to all the rainfall. Well, with this dry years, we're not losing as much. But we see that when we take the pre-plant soil tests in the spring, that we have a certain amount of nitrogen. So then at that point is when we put down our prescription for how much nitrogen to apply to the tomato crop.
Okay, great. Thanks, Bruce. That brings me to the next topic, which is on nitrogen budgeting. And we had a brief introduction earlier from Bruce Hodeschelt about the new requirements for monitoring and documenting on-farm nitrogen applications and offtake, right? And so I'd like to ask the panelists how that have the new requirements for the Water Quality Control Board changed how you manage nutrients on your farm? Or also, were you doing nitrogen budgeting in some kind of formal sense before already? Can you just talk about that a little bit? We'll start with Tom this time.
Well, the lysimeter studies that I just referred to in Austria and the Czech Republic suggest that there's some kind of a dynamic unique to microbially diverse and active soils with significant organic matter fractions, which allows them to cycle and safeguard more nitrogen. I'm not saying that organic system or compost fertilized systems do not leak nitrate to the groundwater, but they're something that suggests that they're more retentive and that they're able to continue to cycle nitrogen through the biology or the microbiology of the soil and hang on to it better and slowly release fractions of it for plant growth. As far as nitrogen budgeting, when you have responsible people in the research community telling you that the field nitrogen mineralization rate from composts can range from 10 to 50% in a 12-month period, how in the heck do you do a nitrogen budget? Okay, that's dependent on the climate, the weather, the irrigation, all these things. So the fact that we have to have these large pools of organic nitrogen in our systems to make sure that our crops don't become deficient, because you can't afford to fall behind in an organic system on nitrogen. You can't just go out and buy a sack of calcium nitrate and be caught up 2 days later. You've got to put another organic material, maybe even fish emulsion, which is we consider relatively available, but that still has to be digested by the soil microbiology to become available to the plants. You cannot afford to fall behind when you're in an organic system. That's why we keep these large pools of organic nitrogen in the compost and in the organic matter content of the soil so that they can be slowly mineralized. And we do a certain amount of fertigation through our drip system each week. It's talked about breaking up your fertility. We add certain fertility elements every week in our drip system in order to supplement what's going on in through the mineralization of the compost. But
okay, so
you can't get behind the curve in organic, or you're going to be losing money real
And what
fast.
I'm hearing too is
You'll
that capturing that on paper is really challenging.
Yeah, so how do you write a budget for that and
Right.
say, I'm mystified as how we're going to deal with this. It's not going to be easy.
Bruce, how about you on nitrogen budgeting?
Well, I talked about that a little bit earlier, how we do it specifically for each tomato field. As far as the new, state program, that's going to be a challenge. They're asking for, what we're going to put on even before we plant the crops, and sometimes we're switching fields and changing things around, and their reports are based on a certain piece of property, and so you really don't know ahead of time what you're going to put on out there, because sometimes you plan on planting one thing and you plant something else. But at the end of the season, it's something that, we're going to have to be doing. It's going to be a lot of record keeping and paperwork. We are doing the nitrogen budgets, but, in the form they want it reported is more work, And
Is it different what they want from what you've been doing for your own farm use?
Yeah, it's somewhat different than what we've been doing. We're doing it ahead of time. We're not necessarily, at the end of the season putting it all in a form they want it, which we're going to start doing now. I mean, we all know, if we've been paying attention for very many years, that this was going to come eventually, as far as, basically prescriptive fertility, where we're going to have to document what we do. May have to, get some person who has a license, a crop advisor, to give you a recommendation for fertility. They've been doing it in places in Europe where they've had nitrate problems in groundwater for decades. And so it was a matter of time before we were going to have to do that. But it's one of the things we're looking at on our farm is just some new software for data management, because the data is somewhat overwhelming now with all the reporting we have to do to the different agencies. And it's not just the government agencies. The processors are asking for that data too. So we're reporting to our processors about water use and fertility management and those kind of things also.
Okay, and that is something I wanted to ask about too. So you are finding some software out there that's useful for this, or
I'm trying.
No, still working on it. Okay, Mike, how about you?
Very similar to Bruce. We've already been doing nitrogen budgets for quite some time, so it hasn't really changed anything. The only thing that's changed is they require it in March, and so I spent a day and filled out a 5-inch high stack of papers on what I was going to plant, which 90% of it I didn't know what I was going to plant. So I'm going to.
So the timing is really an issue of when it's required.
It's a fluid process. So, I mean, hopefully next week we'll have finally figured out what we're going to plant this year. So then I guess I can go back and spend another day and fill it out again. So.
Okay, and software, are you finding things that are useful? Or?
I mean, just Excel.
Okay.
The software, again, what Bruce was saying, there might be some potential there for data management because of all the stuff that we have to do. But, nitrogen budget's fairly simple. You can set one up in Excel, and then it's also flexible, so you can change it from field to field, crop to crop fairly easily.
Okay, I'm going to have one more question, and then we'll open it up to the audience. But I wanted to ask each of you, and I think, Tom, you already at least partly answered this, but if you have any requests for UC Davis or any other researchers on work that should be done in nutrient management that would really help you in your farming operation. So, Bruce or Mike?
I've already mentioned this to a few of the researchers the last couple of years, but and I think we're working on it, and lysimeter data can do it. But our fields are variable, so we can put soil moisture monitoring equipment out there. But if you put it over every soil type in enough places where you have a statistically valid view of what your soil moisture is, it gets expensive. Not only buying the equipment and installing it, but just the monitoring. You need to monitor it every couple days, every 3 days. You have to be out there. Somebody has to be out there. Or you get the newest equipment with the telemetry, and that's even much more expensive. So you can't do a really good job of seeing what's going on in your field underground without a lot of expense. And so to take that to the next step, to getting very cheap, easily handled equipment that can not only monitor your moisture and then start telling you about the nitrates moving in your groundwater is where we need to go, to solve this problem. And I mean, and what the guy from NACWA, NCWA said earlier is of course correct. Just because we stop the nitrate pollution going on, in the next few years from farms doesn't mean we're going to end this problem. So there's huge other problems beyond that. But as far as what we're doing, we need to have a real-time look at what's going down below our root zones. Maybe we don't have to do that forever in every field. Maybe this is an experimental basis that tells us if you monitor your moisture in a certain way and apply it a certain way, you're almost assured of not putting any of your nutrients down below the root zone.
Great. Thanks a lot, Bruce. Mike, any ideas?
Yeah, the one I would really like to see is, with the nitrogen regulation that's coming down the line here, everything is focusing on what's being put on the fields, and it seems like it's an interesting way of regulating it. It seems like you would want to regulate what's coming out the bottom. So in order to do that, you got to know what's coming out the bottom. So I would love to see lots of studies on the nitrogen flux, leaching, various soils, what the effects are, and on top of that, lots of, obviously to measure that, you're going to need sophisticated devices to do that. So we need to start working on ways of measuring it and then making it cheap so that, we can use it out in the field. Because, that would be great. If I know what's coming out the bottom, then I can farm accordingly, and I can, everybody wins in that situation.
Right, great. Okay. Tom, any last words? You already put out the invitation to come to your farm and study the compost-based systems. Any other angle you'd like to see researched?
Yeah, if I was an alien coming down on this planet, I wanted to know about what was going on with nitrogen, I would say, take me to your lysimeter. And I agree with you that we have to find out what's escaping below our farming systems, and I just don't think we have the technology out there to find out how much we are polluting or how much we're not polluting, because a lot of this nitrate that we have in our groundwater now is a legacy of the kind of farming practices that were around 40, 50 years ago. And I think most farmers are much better nitrogen managers today, and we may not be contributing that much more to that situation, other than in maybe some areas of animal agriculture, dairy farms and such. But we certainly welcome the university to be involved in that. We need your support to learn that. And the other thing that was mentioned a bit today that I find very exciting, and I hope the university is really moving into, is the whole study of the soil microbiome, because we have the opportunity to eliminate a lot of the toxics in agriculture by learning how the elegance of the soil microbiome can be manipulated in a friendly way to solve a lot of our agricultural problems. That is one of the most exciting frontiers of science, and there will be some Nobel Prizes for some of you young people out there if you do the right thing about unlocking the secrets of the soil microbiome. It is just more elegant than the stars all in the universe above our heads, and it's right below our feet, and we know so little about it. But we're just getting the tools to be able to see it and begin to understand what's going on there. But in the meantime, let's rely on nature, and because we're always going to be a lot more ignorant than we are knowledgeable. That's a guarantee. So let's be humble about what we know and admit what we don't know.
It's a good thought. Okay, thank you, Tom. I think we have time for maybe a couple of questions, if there's any questions from the audience. Did everybody hear that question? I can just repeat it. Hopefully, let me know if I don't capture it. But the first part was about all the data intensiveness that's being required now. Is that distancing you from farming, or does it help you? Did I capture that? And then the second part is about the possibility of using GIS data and forming co-ops, farmers forming co-ops to be able to access data like that. Is that... So you don't have to buy your own equipment, but can access data. Okay, any comments?
Well, I think there are companies, without forming necessarily co-ops, you can hire people, and with this new technology, there's all kinds of people, organizations coming out of the woodwork with wanting to help us. I've been interviewed by several groups of grad students from Stanford and Davis and various places last few years that think they're going to write an app for me that's going to run my farm. And, you got to be careful about that. I think the data management and a lot of the new technology we have is going to be fantastic for us managing our farms, but we have to make sure we still go out in the fields. I think I learned this from Gene Meow many years ago, that the best fertilizer is the farmer's footsteps in the field. So, we have to keep that in the back of our mind, that we can't sit at a screen or farm, just with a smartphone. But with that being said, I think there are some wonderful technologies out there that are going to help us manage our data and get more data. With the cheap ability of drones now, or their cheap price, I think it's something that any farmer of decent size could afford one to just look at fields. And it's amazing what you can see just with a regular spectral camera, from a few hundred feet up, that you don't see driving around or walking in a field. So,
do you use any apps right now, like weather apps or anything?
Yeah, sure. We all have weather apps on our phone and soil mapping apps and things like that we're all using already.
Okay.
So, we've actually had companies come out and fly drones over our ranch. So, we get a lot of companies that are promising the world with big data. I have yet to see it come to fruition, but maybe in the future it will. It's funny, they always come in and they go, and they promise you this, and they say you can sit at your computer and monitor everything, and I immediately say, I don't want to do that. I want to be out in the field, because that's when you catch things. And even if they tell you something, oh, there's a problem there, you still have to go out and figure out what it is. So in the future, big data maybe there may be value there. I have yet to see it in farming.
Okay. Any thoughts from you, Tom?
I still have a dumb phone because I'm a dumb person, I guess. But I think big data can do a lot of things for us. But I think farming will always be an art as well as a science, just like cooking is. We can certainly be very well informed and more informed by technology and science, but its application on the land will always require art.
Okay, how are we doing for time, Emma? I think we're about wrapping up. If there's one more question from anybody. Everybody's reflecting. Okay, well, I'd really like to thank Bruce, Mike, and Tom for being on this panel and for sharing your insights. Really appreciate it, and I'd like everybody to give them a round of applause. So, evaluations or anything to announce, Emma?